Hi guys, this is IGCSE O-Level Chemistry, paper 22, June 2020, question 1. A mixture of ice and water is left to stand and the ice melts. Which row describes what happens as the ice is melting? Temperature of the mixture. When the ice melts, the temperature of the mixture stays the same. It does not change. Change of state does not require a change in temperature. So this eliminates options A and B, and we will continue with options C and D. The next box says energy change. So the energy change for C is average kinetic energy of particles increases. This would happen when there is a gain in energy. So there is no gain in energy because energy is not being provided. So this is incorrect. And the last one says energy is used to overcome attractive forces. Yes, energy that is present is used to overcome the attractive forces between the molecules of water in the solid state so that the molecules spread out and turn to liquid. So the energy that is present is used up. So this is correct, making option D the correct option for this question. Question 2. Which piece of apparatus is used to measure 25 cm cube of aqueous sodium hydroxide? So we have a dropper in option A, which can only take up a very small quantity of a liquid and we cannot measure in a dropper. B is a conical flask in which we have markings, but it is not used to measure the volume. C is a beaker. Again, it has graduations to measure volumes, but not accurately because there is accuracy in the given value to 1 decimal place. And D is a pipette. A pipette is an apparatus that is used to measure fixed volumes accurately. So the pipette that will be used to measure this volume would be a 25 cm cube pipette. So the correct option for this question is option D. Question 3. Paper chromatography is used to determine the RF values for 4 different food colorings. Which food coloring has an RF value of 0.6? So we will have to calculate the RF value for each of the food colorings given. So for A, it would be 10 upon 25 because the distance traveled by spot A is 10 and the solvent front is 25. So the denominator will be 25 for all RF value calculations. So this will give us a value of 0.4. For B, the distance traveled by the food coloring is 20. So this will become 20 upon 25, which will give us a value of 0.8. For C, we will have 15 upon 25, which will give us a value of 0.6. And D will have the RF value calculated as 5 upon 25, which will be equal to 0.2. Now, since the question asks which food coloring has an RF value of 0.6, this makes option C the correct option for this question. Question 4. The diagram shows the electronic structure of a particle with a nucleon number of 40. Okay, so that is the number of protons plus neutrons. And the number of electrons present are 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there are 22 electrons. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 18 electrons, not 22, 18 electrons. So this particular element, let's call it X, has a nucleon number of 40 and a proton number of, or other number of electrons is, no, we cannot find out the number of protons because these are just electrons. This could be an ion also. So the number of electrons is 18. We cannot call this the proton number. Okay, the table shows the suggestions that 3 students, 1, 2, and 3 made to identify the particle. Student 1 says it is argon. So argon has a proton number of 18, which means number of electrons will also be 18. And it has mass number of 40. So it could be argon. Yes. Student 2 suggested it is an atom of chlorine. So for chlorine, the mass number is 35.5 and the atomic number is 17. So it is not even fitting the data that was provided in the question, which is the nucleon number should be 40. So this is definitely not it. And for the third one, calcium 2 positive. So according to the periodic table, calcium has an atomic number of 20, a proton number of 20 because the nucleon number is 40. And when it has a 2 positive charge, so it will be 20 minus 2, which will give us 18 electrons. So student 3 also suggested an ion which can fit this description. So students 1 and 3 gave 2 appropriate particles, while student 2 gave an incorrect particle. So since students 1 and 3 are correct, option B is the correct option for this question. Question 5. The electronic structure of two atoms P and Q are shown. So 2, 3, 4, 5, 6, 7, 8, 9. P is fluorine and Q is 1, 2, 3. Q is lithium based on the number of electrons that have been shown. P and Q combine together to form a compound. Yes, the compound it will form will be LiF, in which Li will carry a positive charge and F will carry a negative charge. It will be an ionic compound. What is the type of bonding in the compound and what is the formula of the compound? So the type of bonding is ionic, eliminating options C and D, and the formula would be like already written LiF, but Li is represented by Q and F is represented by P, so it should be PQ and not PQ2 as given in option B, eliminating B and making option A the correct option for this question. Question 6. Which statement about the structure of a metal explain why metals are malleable? The electrons can move freely through the lattice. Yes, and this is the explanation why metals can conduct electricity, not why they are malleable. The layers of metal ions can slide over each other. Yes, this is correct. And this is why they can be drawn into shapes, which means they are malleable. Next, the metal ions are positively charged. Yes, because they are more electropositive, but not an explanation of why they are malleable. And there is a strong force of attraction between the metal ions and the electrons. Yes, this is known as the metallic bond, but not an explanation of why they are malleable. Therefore, B is the correct option for this question. Question 7. The bonding structure and melting point of sodium chloride and sulfur dichloride. Okay, sodium chloride is NaCl and sulfur dichloride is SCl2 are shown. Okay, NaCl is ionic, sulfur dichloride is covalent, NaCl is a giant lattice, sulfur dichloride is simple molecular, melting point of NaCl is 801 and melting point of SCl2 is minus 121. So it is a gas at room temperature and pressure. What does sulfur dichloride have? Lower melting point than sodium chloride. Okay. The covalent bonds in sulfur dichloride are weaker than the attractive forces between molecules in sodium chloride. Attractive forces in sodium chloride, it should be ionic bonds, not attractive forces. Attractive forces exist between covalent molecules. NaCl is ionic, so attractive forces makes this option incorrect. The covalent bonds in sulfur dioxide are weaker than the ionic bonds in sodium chloride. The covalent bonds. The covalent bond holds the structure of HCl2 together, not the attractive forces between the molecules. So covalent bond also is incorrect in option A as well as in option B, but ionic bond is correct in option B. So half of this option is correct, not the complete part. Next, the attractive forces between molecules in sulfur dichloride. Yes, there are attractive forces present between the molecules. Covalent bonds are present between the atoms of a single molecule. Are weaker than the attractive forces between molecules in sodium chloride? No, it will have ionic bonds, not attractive forces. And the last one, the attractive forces between molecules of sulfur dioxide, this is correct, are weaker than the ionic bond. This is also correct in sodium chloride. Therefore, option D is the correct option for this question. Question 8. Lead 2 nitrate reacts with potassium iodide to form a yellow precipitate of lead iodide and a soluble salt KNO3. What is the equation for this reaction? So let's write it. PbNO3 twice will react with Ki. So we will need 2 moles of Ki. And this will give us PbI2, which is a solid, a yellow precipitate, and potassium nitrate. So we will have 2 moles of KNO3. And this would be aqueous. So out of the given equations, the equation that matches the equation that we made is the one in option D. This makes option D the correct option for this question. Just a quick overview of why the other options are incorrect. In A, we have the missing molar coefficients of potassium iodide and potassium nitrate. In B, we have got the missing molar coefficient of potassium nitrate. In C, we have got 2 moles of lead nitrate, which is not required. And that's it. That is the reason why this is incorrect. Whereas all the species and the molar coefficient given in D are correct, making D the correct option. Question 9. The Haber process is a reversible reaction. The reaction has a 30% yield of ammonia. Okay. Which volume of ammonia gas measured at room temperature and pressure is obtained by reacting 0.75 moles of hydrogen with excess nitrogen? Okay. So the molar ratio of hydrogen to ammonia is 3:2. So if we have 0.75 moles of hydrogen, so the moles of ammonia would be 0.75 divided by 3 and multiplied by 2, and this will give us 0.5 moles of ammonia. So if we have 0.5 moles of ammonia, so 1 mole of any gas at RTP occupies a volume of 24,000 centimeter cube. So 0.5 moles would occupy a volume of 0.5 into 24,000. So this would give us a value of 12,000 centimeter cube. But this will only be true when the reaction is 100% efficient. The question says the reaction has a 30% yield of ammonia. So 30% of 12,000 is equal to 3,600 centimeter cube. So this makes option A the correct option for this question. Question 10. Electrolytes can be broken down by electrolysis. Which rows are correct for each electrolyte? So we have dilute aqueous sodium chloride. Okay. Reaction at cathode. Cathode is where reduction takes place, and we have aqueous, so it would be hydrogen gas that is being produced. So 2H positive plus 2 electron gives H2. This is correct. And product at anode would be oxygen, because this is dilute and aqueous sodium chloride. So this is also correct. So the row 1 is correct. 2, concentrated hydrochloric acid. So since it is concentrated, hydrogen will be produced at the cathode, which is shown, and chlorine will be produced at the anode, which is also written here. So this row is also correct. Row 3 has molten aluminum oxide. Molten aluminum oxide would result in the formation of aluminum at the cathode, which is not written here, and the product at the anode would be oxygen, which is not written. So this is incorrect. And row 4 has concentrated aqueous sodium bromide. So this would have hydrogen being produced at the cathode, which is not written here, so incorrect, and bromine at the anode, which is written here. So half of this row is correct. Since only rows 1 and 2 are completely correct, this makes option A the correct option for this question.